So about how the exam works, especially someone having the doubt whether the oral presentation of the project is mandatory or not, it is mandatory. So it works like this. You choose an exam call in which you want to present the oral project as a group. So for instance, next session, you can either choose the first call or the second call, the one in January, I don't know the day, and the one in February, which I think is the 13th or something like that. If you want to do the oral presentation of the project in the first call, you have to submit the project by the day of the first call. If you want to do the oral in the second call, you have to, the oral presentation of the project, you have to submit the project by the day of the second call, and so on. So anytime you want to present the project, you have to submit the project, so the essay, by the day, the official day of the call. Yes. It's better if you do. Of course, let me think. Yeah, no, do it, yes. Subscribe for... Yes. For the written, it would be mandatory for official reasons. I don't think it would be mandatory for the oral presentation, but it's much better if you do it so that we organize ourselves better. So please, yes, subscribe to any call independent on what you are doing in that call. Yes. Se vieni allo scritto vuol dire che fai lo scritto, se non vieni allo scritto vuol dire che non fai lo scritto. Cioè se io non ti vedo so che non lo fai. Se mi mandi il progetto so che stai presentando il progetto. That's the main idea. Sì, così ho l'elenco degli studenti fatto bene. Okay. Yes, the thing I was saying. Maybe there was some confusion because in the explanation of the exam there is written that the oral exam is not mandatory. That refers to an actual oral that we can decide to do if there is some dubious situation in terms of marks, but this almost never happens. So normally it's 16 points, the written part. Then when you submit the project, we correct the project, send some revisions. You can work on those normally very small revisions. In the period between the day of the call and the day of the oral presentation, you present the project. It's 16 points also for that, and then we sum up the points, and that's our mark. Yes. Preferably in English, because we do like a session with all the oral talks together, so that also your colleagues understand. That would be great. Yeah.
We're gonna take the exam the first one, the paper the first one. We do the presentation in the second
one. If you want, I think so, but then you cannot register the mark in the first call. You would have to subscribe to both the first and the second. Yes, because if you do the exam on the second call, it is very likely that the window for registering the mark in the first call is closed by the day you present. Yeah. I mean, for instance, it's the same as if you do the written in the first and the presentation in the second. I keep the written mark from the first call. It does not expire if you don't present the oral presentation right in the same call. So I keep that mark. You present in the second, but I mean, you can do it. I don't know how smart it is, because if you want to present in the second call, you can also submit the project by the second call, and so you have more time to finish it. No. If you want, no. Just you have to submit the paper before you present it. I accept people coming to the written who have not submitted the project yet, but that would mean that in that call you can only do the written part. Then you would have to subscribe again and submit the project by the day of the second call to present in the second call. So the two parts are separate. You can do one in one call and the other one in the other one. The only rule is when you want to present the project, you have to submit the project by the day of the written test of that call. Whether you want to do the written test in that call or you have already done it or you don't want to do it yet. This is so that, because our priority is that groups present together as groups. But we understand that maybe people have different plans in terms of which exam to take in which session. So if there are 3 people that want to take the exam in 3 different calls, we still have the possibility to make everyone present in the first call so that the first student can register the mark or in the call that you want. But our main aim is to make you present all together, and then so that we don't hear the same thing twice. No, kidding. Okay, other questions related to this? I imagine that. Okay, yeah, we have time. I think we have 2 examples of written tests to do. I think we can make it in 2 hours, so we have some time for discussing this matter. Yes. 10 to 15 minutes. It's 3 hours.
3 hours for introduction?
It's normally 2 theory questions and 1 exercise.
There are some questions after the presentation of the.
Yeah, there is always some minutes for like questions, discussions, normally on the project. So curiosities or things that you could have done, like limit development, if you imagine. The only thing is you say something really stupid that relates to topics in the course, we may question you about that just to see if it was just anxiety or you haven't studied it. But it doesn't happen. Normally it's just discussion on the topic of your project.
And the weight of the oral part and the written part is the same?
Yes, it's 16 points, and then we do the sum. So if the sum is above 30, it's 32 now. Okay. Other? Yes. No, esatto, great. No, there's a minimum of, I think it was 7 or 8, something like that. I have to check. But yeah, we would tell you, like, if you get an email with the points, it means we are keeping it. If you get an email that says you didn't pass the written part, it means we are not keeping it. So in my experience, normally what happens is, if you pass the exam, it's well above the minimum. I mean, the cases where you are on the limit are very rare. Normally, what I see from my personal experience is you either do kind of well up to pretty well, amazing, fantastic, or very bad. So that case is very rare that you have these limit points. But I think it's 7 or 8 points, something like 8, probably 8. Yeah. Now that I recall it, 8. Yeah, I think it's 8. Okay, you can think about it. I'm here. Okay. Oops. No, you're passing. Okay. Let me start, I would say, with, yes. Oh, yes. But I'm not sure I'm able to see from here. Does anyone? Ma voi lo vedete da dove? Ah, aspetta. Aragna? Io non vedo da qua. C'è qualcuno che è su Webex che può nel mentre... Ah, ok. Allora, aspetta, riesci a staccarlo e venire qua un attimo, così manovreremo? No. Non c'è il ragazzo che mi aiuta di solito. Ah, fantastico. Ok, ma c'è. Adesso ci pensiamo con noi. Allora. Ok. Perché oggi tra l'altro mi servono lo schermo e cose contemporanee. Oh, aspetta, non so se voi riuscite poi a vedere sia lo schermo in condivisione che la live.
Sì, a casa sì.
Ok, allora va bene.
Ci riesce a cominciare.
Sì, dovrebbe vedersi. Ok, fantastico. Yes. Dici scritto in inverno, presentazione in estate? Sì, li tengo, mi sembra, per un anno solare. Non accademico. Per cui... Sì, anche perché c'è il mondo di gente che dopo questo corso va in Erasmus, per cui per forza se no diventa un disastro. Sì, si può fare. Ok, can we? No. So I've put on deep, I think, 6 past exams that you can train on with a folder of solutions. Only the names of the solution file are a bit weird, so it's a Christmas game for you to associate the right solution to the right exam. Have fun with that. And today we are doing other two, so not those that are in there, so that you have 2 extra ones. One that is this one from 2018 and the other one from last year. So I'm just doing the exercise here, then you have plenty of theory questions in the other exams. So question from 2018, this was September the 5th, and the date matters in this exercise. So the text is Mr. Altavilla, I don't know who Mr. Altavilla is, from my previous teaching assistant, he always wrote funny exam texts, planted his 0.6 hectares field in Brizuela, which is a place in Spain. He planted this field with maize on May the 1st. So, base field 0.6 hectares, May the 1st. And he's going to harvest on September the 15th. So, yesterday evening, meaning September the 4th, because this was an exam on September the 5th. On September the 4th, Mr. Altavilla measured the soil humidity and he checked weather forecast till September 15th, so the harvest date. And we have the data in the table. I will give you the data in a minute. So based on all the data that you have, the question is, does Mr. Altavilla need to irrigate his field in the next days? So we are on September the 5th. Harvest is on September 15th. So we want to know if in those remaining 10 days we have to irrigate or not. Considering that, other question, since sowing, so since May, he has irrigated his field 2 times, once in June and once in August. How much green and blue water were required by Mr. Alparilla? So the data that we have are a table with evapotranspiration data and crop data too. So we have reference evapotranspiration, crop coefficient, and the root vector. And we have it for all months from sowing to harvesting, of course. So we have May, June, July, August, and September. So let me fill the table with the numbers. 4, 4.1, 4.3, 4.5, 0.3. And then we have okay. So other data that we have, of course, Mr. Altavilla measured soil humidity, as we said, at the end of September the 4th. So we can say that that's our initial humidity, which is equal to 159 millimeters per liter. Then we have our soil data. Wilting point is 110 millimeters per liter, and field capacity is 220 millimeters per liter. and the depletion fraction is 0.6. Then we know that he also checked on weather forecasts for the upcoming 10 days. And in the exam, you have the whole weather forecast. But now, just for sickness of brevity and clarity, I will give you the intensity of the rainfall events when we have them. So we know that on September the 7th, we have 4 millimeters of rainfall. On September the 13th, we have 75 millimeters of rainfall. And on September 14th, we have 12 millimeters of rainfall. The rest of the time, from the 5th to the 15th, we have sunny days. And so everything very nice and easy. Okay. Questions on the data? Questions on the questions? Okay. So what do we do? We need to understand if we get to the point where we have to irrigate between September the 5th and the harvest date, which is September 15th. So we have the data at the end of September the 4th. So what we can do is start from here, do the hydrological balance, and see if we get to the MAD at some point, so the threshold for irrigation. MAD, which we still have to calculate, so let's do that first. Knowing wilting point and field capacity and the depletion fraction, we can calculate the readily available water, which is, as you know, depletion fraction times field capacity minus wilting point times the root depth. So we are in September, so the root depth is 1 meter. So it's 0.6 times 220 minus 110 millimeters per meter times 1 meter of depth. Which is 66 millimeters. Okay. From the readily available water, we can calculate the maximum allowable depletion, which is just field capacity minus the readily available water. If you get confused about that, you just need to memorize the schematization of the soil layer, and that should make it easier for you. So our usual rectangle, where this is the root depth, then you have field capacity wilting point, maximum allowable depletion. This is readily available water, and this is total available water. So if you remember, if you have a more photographic than conceptual memory like myself, remember this drawing and you know everything you need to characterize soils. Hydrology. So MAD, field capacity minus maximum readily available water. So it's 220 minus 66, which is should be, è giusto? Sì. Okay, yes. 154 millimeters. So if we go at some point with our water balance below 154 millimeters, it means that we have to irrigate. So we are starting from 159, so it's very likely that we get to 154 very soon, but we also have a 4 millimeter rainfall event right 2 days after beginning, so we have to check. So the only thing that we can do is day by day, with lots of patience, go through it and see where we go. So September the 5th, the initial value of humidity, since our root depth is 1 meter, 159 millimeters per meter corresponds to 159 millimeters, because our control volume is 1 meter deep. So initial humidity is 159 millimeters. At the end of day 1, final, we have the initial. What do we have? Fluxes. Evapotranspiration. The only thing that we have at the moment is evapotranspiration. No rainfall, so we are not above field capacity, so no deep percolation. We are not below MAD, so no irrigation. The only flux that we have is evapotranspiration. Evapotranspiration, I just cleared the table, but we have the data for reference evapotranspiration month by month and KC values month by month. So we are lucky because we have it month by month. We don't have the graph, so we don't have to do the linear interpolation. This is sparing you some time. So we know that in September, KC values are around 0.5, and the reference evapotranspiration is 4.5. So crop evapotranspiration for the whole period is Kc times Kt0, meaning 0.5 times 4.5, meaning 2.25 millimeters. If you want to be very precise, millimeters per day. So 159 minus evapotranspiration 2.25 is equal to 156.75 millimeters. And the first day is over. Yes? What? Yeah, the reference, you weren't there, or were you already there? I don't know. The reference evapotranspiration is provided. AT0, you have, in this exercise, you have monthly values of AT0 and monthly values of KC. So you just have to check in which month you are, and you have everything. Okay. So since 80 and KC are constant over the month, we can keep this number here for all the days. So very easily, on September the 6th, the final soil moisture will be the initial, meaning the final of the previous day. So 156.75 minus, again, no rainfall, no irrigation, no deep percolation, only evapotranspiration, which gives us 154.5 millimeters. So we are just above the stress threshold. What happens on the 7th? Again, we start from the final value of the previous day, and then we put all the fluxes. So minus evapotranspiration, and in this case, looking at the weather forecast, we are expecting a 4 millimeter rainfall event. So at the end of day 7, we will have the moisture at the beginning of the day 7, meaning at the end of day 6, minus the evapotranspiration on day 7, plus rainfall on day 7. This should give you 156.25 milliliters. So this delays a bit our irrigation, but it won't probably stop it because next rainfall is on the 13th, and we are very close to stress. So already here we could expect that we have to irrigate, but let's check it. So on September the 8th, we start again from the final of the previous day, 5, no rainfall in this case, so minus 2.25, and that's it. And this gives you 154 millimeters, which is exactly the stress threshold. So we have reached the maximum allowable depletion. There is still 1 week before harvest, but I cannot wait to irrigate because I am already at maximum allowable depletion. So no need to do further calculations because you have arrived there. It means since on the 9th of September you have no rainfall, you already know that on the 9th of September you will have to irrigate for sure. So since the question was, we did not ask to do the whole water balance. I mean, if you do it, it's great, but it's not needed to answer the question. The question was, does Mr. Altavilla need to irrigate his field between September the 5th and September 15th? The answer is yes, on September the 9th. Then, very probably, if you go and do the whole water balance, you will see that at September the 13th, you are still probably closer to fill capacity than you are to maximum allowable depletion. So probably a lot of this rainfall will go into deep percolation because it's also a lot of rainfall. It's 75 millimeters. It's quite a big event. So you can do all your considerations, like probably depending on the reaction to stress of this crop, it could have been worth not to irrigate or to irrigate just a little to make it survive until the 15th, but then you don't know, and so on and so forth. But the important thing is on September the 9th, we reach maximum allowable depletion. So based on our knowledge and our schematization of the process, on September the 9th, you have to irrigate. Questions? Yes.
If you want to irrigate, let's say,
Yes.
the amount of water is the regular water.
Yes, we are assuming, I mean, nothing is written here, so we can assume a surface irrigation system because it's a maize field. It's a maize field in Spain, so yeah, either surface or sprinkler. You don't do drip irrigation on maize, it's impossible. So it's very likely that you have an irrigation approach that starts at MAD and goes to full capacity. So yes, you would irrigate an amount equal to readily available water. Other questions? All good? Okay. Second question was to calculate how much green and blue water were required throughout the season. So from planting to harvesting, knowing that Mr. Altavilla irrigates once in June and once in August. And once in September, we know now. So it's actually 3 irrigations. So don't forget the one that you found. How do we do it? So the data that we have here, I mean, we don't have weather data for the whole time, so we cannot do the water balance from May the 1st to September 15th, also because it would require 3 days and not 3 hours of exam. It's, how long is it? It's 150 days more or less. But we have monthly values of reference evapotranspiration, monthly values of Kc, and we know when we irrigate, and based on the system that we can assume, we know how much we irrigate each time we irrigate. So what can we do?
With water requirement.
Exactly. We can easily compute the crop water requirement by doing the sum of crop evapotranspirations month by month. And then we subtract the blue water because we know how many times we irrigate and the irrigation amount. And so we have the blue water, we have the crop water requirement. Crop water requirement minus blue water equals green water. So let's do it. So we can say that the crop water requirement is the sum for I going from May the 1st to September the 15th, so from planting to harvesting, of each month it's 80. Each Kc and the duration of each month, because we have daily evapotranspiration rates. It's millimeters per day. So we have to integrate over each period. So written like this, it sounds confused, but it's actually very simple. So in May, we have a reference evapotranspiration of 3.2 millimeters, a Kc value of 0.3. So every day we evapotranspire this much. How many days in May? 31. And this is May. June, reference evapotranspiration is 4. Kc value is 0.7. Days in June, 30. July, reference evapotranspiration 4.1. Kc 1.1. Days, July 31. August, reference evapotranspiration 4.3. Kc 1.1. Days in August 31. September, reference evapotranspiration 4.5. Kc value 0.5. Days in September, how many? 15. Bravi. I was expecting a 30 over there. 15, because we harvest on the 15th, of course. So if you do all these products, you have, let me copy. 29.76 complexively over May, plus 84 millimeters over June, 139.81 over July, 146.63 over August, and 33.75 over September. Putting everything together, it's a crop water requirement of 433.95 millimeters crop water requirement. Now, blue water. Mr. Altavilla irrigates in June and in August. You would say this information is not useful. I just do readily available water 3 times. There is one reason why this information is actually useful. This is like probably the extra point of the exam. It's a very subtle thing. Do you find it? Yes, exactly. In June, the root depth is not 1 meter. So the readily available water is slightly, small, no, not slightly, by 25% smaller, because it's calculated over the root depth. So we irrigate, in theory, then we have to see if Mr. Altavilla is that precise in his irrigation. This is why this is the extra point. We don't really know. But if we want to do things in a very, let's say, philological and precise way, that's the way to do it. So we have a blue water that corresponds to, what was the amount before? 66 millimeters. 66 millimeters in June, no, in August and September. while in June, we would have, so it would be 0.75 times depletion, that was 0.6 times 220 minus 110. Calculator. Oh, you can do it if you want. How much? 49.5. Okay. So an experienced farmer would see this difference because they normally don't. I mean, Mr. Altavilla has a humidity measurement tool. We have seen it, but also normally what farmers do is based on the experience, they see when the crop starts getting into stress, so they can more or less intercept the MAD even if it changes, and they can also see more or less when it reaches field capacity, or they stick the finger into the soil and they know how wet it has to be. So we could expect that Mr. Altavilla is able to see this difference. So to compute the total blue water, it's 49.5 ones plus 66 plus 66. This is the August irrigation, this is the September irrigation, and this is the June irrigation. How much is the total? 151.5. 31. 8. Yeah, makes sense. 181.5 millimeters of blue water. And so green water is just crop water requirement minus blue water. And you can tell me how much it is. $252.4.
Irrigates once in June, once in July, once in August.
No, once in June, once in August.
Once in
Yes, the one we found.
yes. But maybe irrigate the price.
Maybe, but if you look at the numbers, it's very likely that not, because you see, you have the rainfall data on September 13th. So you know you irrigate on. I mean, you can do a quick check if you want, but there's no need to do the full water balance to see it, because you are at field capacity on September the 9th because you irrigate slightly below field capacity, and so you know that it does not take 4 days to go. I mean, it takes more than 4 days to go from field capacity to meeting point, and 4 days after you have lots of rainfall, and then 2 days later you harvest. So even qualitatively, you see that it's not twice. Actually, probably most of these 66 millimeters in September is wasted because you only use it for 2 days, not 3. So, okay. Other questions on this one? No. Okay. So the data on the area of the field were completely useless, but that's okay. That's not a problem. You don't have to use all the data that are presented to you. I mean, you could do the calculation in volumes by multiplying everything by the area. Not really useful. It's not specifically asked for. So manage your time wisely and do to the other questions, I would say. If it's specified to calculate volume, then yes, please calculate the volume. Okay. Break or second exercise? It's also second exercise. Okay. So second exercise, I need to share the slides because it's a lot of data. I don't want you to copy all of them. Hmm? Yeah, it's on Webex, so you can take them from there. Okay. So we have 4 countries here, A, B, C, and D. 4 different countries. We know that country D needs to import 3 megatons of maize every year. So they probably have a deficit in maize production, or they really love maize, or whatever. The matter is, they need to import 3 megatons per year of maize. We assume that these 3 countries here, A, B, and C, are the exporting countries. So we can choose to import either from A, or from B, or from C. And we want to know which one we should import from if our target is to minimize virtual blue water import. The data that you have are crop data, climate data, soil data, and irrigation data. So you basically have everything you need to compute water needs for maize in each country. And we have to choose the best one in terms of reducing as much as possible the virtual import of blue water. We also have yields, of course, production data. So what would you use to solve this exercise? What would you do? Ideas? Possible strategies to go through it? There are at least 2 that you can do, actually. I mean, very similar, but I remember when I corrected this exercise, I've seen 2 main strategies among the students. 2 schools of thought about how you can solve this. Yes?
We look at
Yes?
we look at the water requirement.
Okay, so you say, okay, yes, groundwater requirement in each place, how much it would then take to produce 1 ton, you say? Yeah, so basically a water footprint. Yeah, okay, yeah, that's the main idea, actually, okay. So the main parameter can be a water footprint. Since we have to import the same quantity from everyone, the criterion that makes us choose will be for each ton that we import from a given country, how much blue water has been consumed in that country to produce that ton. You can also multiply everything by 3 so that you have the total blue water associated to the total production that you need in each place. But if country B is lower than country A for 1 ton, it will be for 3 tons as well, because you're just multiplying both sides of the equation by 3. Okay. So basically, saying I want to import from the country that consumes the least blue water to produce the same amount of a product means I want to import from the country that has the lowest blue water footprint. Because if you think of the definition of water footprint, it's the amount of water required to produce, the amount of blue water for blue water footprint required to produce a given amount of a product. So you can either just calculate the water footprint, and that would be for 1 ton, for instance, or take everything by 3 and do the total volume that you would use, but the results would be the same. So basically, the exercise is asking us to calculate blue water footprint of maize production for countries A, B, and C, and tell us which is the lowest. So I would say we start from country A, so that we don't get confused. So country A, what happens in country A? We have planting month in May, an initial phase that lasts 1 month, a growing phase that lasts 1 month, a middle phase that lasts 2 months, and a final phase that lasts 1 month. So we have to reconstruct the Kc values, because we have the 3 Kc values and the 4 growing period. So in this case, we are not as lucky as before. We have to think of our Kc curve. But what we can do is we can do the calculations month by month. So we don't have to calculate this. This would take a lot of time that's not necessary. We don't need to calculate the evolution of the Kc value day by day by integrating the whole thing. We know that the Kc in the initial phase will be the initial Kc value. Then we need to integrate evapotranspiration over this phase here, meaning that if we have a constant evapotranspiration, which we have for country A, it would be the June one, 3.3, and a changing Kc. This means that our our crop evapotranspiration from the beginning of the month to the end of the month would have this behavior, where the initial value is 0.35 times 80, and the final one is 1.15 times 80. I'm interested in the total evapotranspiration that happens between here and here. Meaning, think of integrals, but it's simpler than that. This area over here. So, this day I evapotranspire this much. Second day it's this much. Third day is this much. Fourth day is this much. At the end, the total evapotranspiration would be this one. Meaning the area of this shape. If you go back to middle school, this means this one plus this one times this one divided by 2. So it's the Kc initial plus the Kc final times AT0 divided by 2 times the duration, so 1 more. So in the end, and this should make a lot of sense to you, if we want to take a single Kc for the growing season to multiply by AT0, it's just the average Kc of the beginning and the end. This is teorema della media, analisi di. So when we have a constant Kc value, to calculate the whole evapotranspiration, it's just Kc times the reference evapotranspiration. When we have a linearly changing Kc value, it's just the average of beginning and end times the evapotranspiration that you have in that moment. Is it clear? I hope this was not too much of a journey in mathematics. I see some dubious faces. I don't know if I have to leave you time to think about it or if we have to move on. Ok, you say it's fine. Okay. Siamo perplessi? No, tosto. Okay. Great. So let's do some evapotranspirations for country A. Let me write country A. In May, we are in the initial phase, so we have a constant Kc. Means that our reference evapotranspiration is, I lost it, 0.35 times 3.2, which is equal to 1.12 milliliters per day. So, Kc of the initial phase, evapotranspiration of May for country A. In June, we have an average evapotranspiration rate that is the average Kc, so it's 0.35 plus 1.15 divided by 2 times the reference evapotranspiration for June, that is 3.3. And so we have 2.475 millimeters per day. In July, we have reached the middle phase, and yes, because it's 1 month of initial phase, 1 month of growing phase, and then we have 2 months of middle phase. So in July, our Kc is constant 1.15. So we have 1.15 times ET0 of July 3.4 equals 3.91. August, same thing, only the evapotranspiration changes because it's the 2nd month of middle phase. No, the evapotranspiration is also the same. Yes, 3.4, so it's 3.91 millimeters per day. And final month is the month of September, where we are in the final phase. September, the evapotranspiration is to the descending Kc, so we have to do the average again. Whether it goes up or down, it makes no difference because you do final minus initial. You may have a minus, but you know that a negative evapotranspiration does not make sense, so probably you mess up with initial and final. But it's a linear thing, so the area below it is still a in English. I mean, same shape as before, so it's still an average Kc that you have to do. Outside. Check it. So September, we have to do the average Kc, so it's 1.15 at the beginning, 0.5 at the end, divided by 2, times the evapotranspiration of September is 3.1, meaning 2.56 millimeters per day. So we have, these are average daily rates of evapotranspiration. For the initial and the middle phase, this average rate corresponds to the actual daily rate of every day because we have a constant Kc and a constant evapotranspiration. For the growing phase and the final phase, this is the average of a linearly increasing or decreasing, depending on the phase, evapotranspiration rate because of constant reference evapotranspiration, but linearly changing Kc. But again, due to theorems of average and integration, if you do the average times the duration of the period, you get exactly to the same result. It's not even an approximation, it's just mathematics. So what you have to do now is just taking the daily rate, multiplying it by the duration of the month in days, summing up all together, just as we did in the previous exercise. And that would be your crop water requirement. So I can say that crop water requirement is equal again to the sum of ETC times D for each month. I don't want to do all the calculation again, so I just leave you with the solution. It's 428.19 millimeters. This is crop water requirement. How do we get to blue water? What information do we have in terms of irrigation and blue water? We know that for country A, blue water is 30% of the crop water requirement. So very easily, we just calculate the 30% of the value that we found, and that's our blue water. Blue water, 0.3 times 428.19. It's 128.46 millimeters. Okay. Now that we have blue water, we can calculate the blue water footprint. If you remember, I mean, here's where the two ways that I was saying before separate. I will show you the simpler one because we prefer simplicity. So the complicated one would be finding from the yield how many hectares you need to produce 3 tons of maize. Then multiplying this area in hectares by the blue water to find the volume, divide the volume of water by the total production that you need, and that would be the water footprint. But if you remember when we did the exercise on water footprint, we said that for water footprint of agricultural products, the result is independent on the area. If you remember, we said that water footprint for a crop is water volume divided by production, as for any good for which you want to calculate a water footprint. But for a crop, this means water requirement, either blue or green or total, in millimeters, so expressed as a water height, times the area of the field, divided by, how do you calculate the production? Yield times the area of the field. So these two go away, and we have that water footprint of agricultural products is just water requirements divided by yield. This you should already have from the exercise on water footprint that we did. Just a reminder. Meaning that we don't have to do all these weird calculation I was saying before, getting the area from the yield, obtaining the production, going back. We have the yields. We have blue water. We just need to divide blue water by the yield, of course, taking care of unit measure. And we have the water footprint. So in our case, we are interested in, we are interested in blue water footprint. So we can say that blue water footprint is equal to blue water divided by yield. My blue water is, I don't remember, 128.46. Okay. Millimeters. And my yield is 6 tons per hectare. Now the complicated part. No, unit measures. So we need to get rid of the hectares. We done that in the exercise too. $128.46 millimeters divided by 6 tons per hectare. I want to get to hectares at some point. Remember, what does millimeters mean? It's if I imagine to create a uniform rectangular space of water over my field, regardless the area of the field, this is my height in millimeters. So let's first get to meters just to make it easier. It's 10 to the minus 3 meters per millimeter. Hectares below here. I can transform the hectares in square meters very easily. So this would be, since it's at the denominator of the denominator, I can put it above here. So it's times 10 to the 4th square meters per hectare. So the hectares go away pretty well from here. The millimeters go away pretty well from here. So here we have a factor 10. Here we have meters. Here we have square meters. So finally, the unit measure is exactly what we were looking for. Cubic meters per ton. Very nice. 128.46 times 10 is 1,284.6, which we have to divide by 6. So in the end, we have 214.1 cubic meters per ton. Okay? Is it clear? When you don't know where to go with the conversions, just try to put everything to the very basics, like meters, kilos, seconds, everything there, and then take your time, go through it, and eventually you will find something good. Normally, once you do it a few times, you start to memorize that to go from millimeters to, let's say, cubic meters per hectare, so to something where you can do this conversion here, you have to multiply by 10. Normally, you always find a 10 factor. But to know if it's to be multiplied or to be divided for, you need some training. If you start doing the exercises like the exams I put on Webex, you will see that after a while it starts to get automatic. You know, yes, here's a 10, or yes, here's a divided by 10. But at the beginning, I would say just put everything in meters so that everything goes nice in the way, and you should get out of it pretty easily. So 214.1 cubic meters per ton. Another trick to check if you're right or wrong during the exercises is always look if the numbers make sense. So if you find a water footprint on the hundreds/thousands of cubic meters per ton, you know you are in the right place. If you start seeing like 1 million cubic meters per ton, there is something wrong in some conversion. If you see 0.1 cubic meters per ton, there's something wrong in the other direction. And also for millimeters, for areas, always check that your results have some sense from the physical point of view, because we always do exercises with real data. So these are normally like data from FAO stat or from CropWatt or from wherever. So normally they should be results with some physical sense. So that's also a thing that you get while training and studying. You start to learn what should be the order of magnitude of things, and it helps you a lot in understanding if your results are making sense or not. Okay, blue water footprint of country A, we have it. Country B, I think we have similar information for country B. Blue water is 40% of crop water requirement. The calendar is different, I think. Yes, we plant in June, and we have an additional middle phase month. A little different in the weather, of course. Procedure. We have to calculate evaporation rates month by month, thinking of the right variations in KC, and then we sum up everything and we get to the blue water. So planting is in June. June, evapotranspiration of the crop. In which phase are we? Of course, in the initial, if we plant. So it's the first KC, 0.4 times the June evapotranspiration, 3.1. So 1.32 millimeters per day. July, growing phase. So average KC, 0.5 times 0.4 plus 1.1 to do the average, times the evapotranspiration, which is 3.2. Result is 2.4 millimeters per day. August, middle phase. So constant KC, 1.1 times reference, 3.3, is 3.63 millimeters per day. September, second month in the middle phase, so same KC value, probably different evapotranspiration, 3.2, no, 3.4. Wait, higher in September than in August. 3.4, so the result is 3.74 millimeters per day. October, last month in the middle phase. So again, same KC value, different evapotranspiration, 3.2, we finally start decreasing, and it's 3.52 average evapotranspiration rate. November is the final month, so we are in the final phase. So we have an average KC because it's a descending KC phase. So 0.5 times 1.1, which is the middle, plus 0.45, which is the final, times 2.9 equals 2.25 millimeters per day. Total crop water requirement is just as before the sum of all evapotranspirations by the duration of each month, and the result is 515.35 millimeters. So the blue water is, as per the table, 40% of the crop water requirement, and it's 206.14 millimeters. I went quick on this because it's the same as the last one, so I hope it's fine. If you have questions, just scream and stop me. Blue water footprint is blue water divided by the yield. So it's 206.14 millimeters divided by how much is the yield in country B? 8. Ooh, productive. 8 tons per hectare times 10 to the minus 3 meters in a millimeter times 10 to the 4th square meters in 1 hectare. Hectares and hectares, millimeters and millimeters, 10 to the minus 3, 10 to the 4th. $257.7 cubic meters to produce a ton of maize in country B. Okay. Country C. What do we know? It's irrigated twice with surface irrigation, and we also know that, differently from probably the previous exercise, all the water reaching the field is used by the crop. So what do we do here?
Calculate quantity of water for irrigation.
Quantity of water for irrigation based on what? Field capacity. I've heard some field capacity. Yeah, third table. We haven't used that yet, so it's time to use it. Third table. So we don't need to go, thank God, for the third country, through the whole calculation of crop water requirement, because we have information to calculate directly the blue water. So we know that we irrigate twice with a surface irrigation system, meaning from MAD to field capacity. And we also know that all water is consumptive. So we can directly calculate the blue water as twice the irrigation amount, where the irrigation amount is equal to the readily available water. So root depth times depletion times field capacity minus wilting point. Root depth 1.2. Depletion 0.6. Field capacity 210. Wilting point 120. 64.8 millimeters. Twice this. $129.6 millimeters. And so the blue water footprint is just as before. Blue water divided by yield, 129.6 divided by 7 tons per hectare. Now you have learned that it's 10 and so the final result is 185.1 cubic meters per ton. So where do we import from? Country C. Right. Mm-hmm.
If we would have been asked to calculate the rainwater footprint in this case,
Mm-hmm.
we probably have to do the same of the previous exercise, so whatever requirement times blue water and then divide by the
Yes. Yes. And the total water footprint would be the sum of the two water footprints, or alternatively, crop water requirement divided by yield.
Okay.
You get to the same value because it's linear. Okay. Other questions or doubts?
Prof,
Yes?
a posto la maximum allowable depletion pari alla total al wilting point perché consumano tutta l'acqua
Dove sei?
per l'irrigazione.
Qui?
Sì,
No, c'è la depletion fraction qua.
ok, grazie.
Quindi è comunque fino all'MID e basta. Fill capacity meno wilting point ti dà la total. Depletion fraction ti dà la readily. Quindi stai irrigando fino all'MID, dalla fill capacity all'MID, non dalla fill capacity al wilting point. Yes? No, it can also be on the first classes that we have done. Yes. Yeah, I won't likely go in. I mean, I won't ask you to name all the components of system. I mean, not by non tutte le valvole, but just knowing that it has mains and laterals and some devices to control the pressure and some filters. That yes, you're required to know that. And also the whole stuff on soil parameters and water potential. Yeah, that's part of possible query questions. Yes. Okay. So I'm done with the exercises. So we have like 40, 50 minutes to discuss whatever you want. Otherwise, I can call it a day. Yes.
But in this case, we foresee that different water is on green water and blue water.
Yes. I mean, in all cases, actually, normally, because the concept of water footprint. Oh no, you were asking about virtual water. Okay. With virtual, by definition, I got confused with water footprint. Virtual water, by definition, is water that is embedded into the production of something. So we normally talk about virtual water trade because it's the embedded water in traded products. So by trading a product, you are virtually trading the water that has been used to produce that. So in this case, we say we minimize virtual blue water use equals saying we minimize, how can I say it, the blue water consumption associated to the product that we are importing. And so it means, like, the concept of virtual water is just a lens to move the water consumption from where a good has been produced to where it has actually been used. So that when you do analysis on multi-countries, you associate the water to the right consumer. Because, I mean, if we eat stuff that has oil palm, it's us that are consuming the blue water in Indonesia, not the Indonesian people. So that's what it's used for. So in this case, this country D, wants to minimize its virtual blue water use, meaning that it wants to take goods from countries that do not need that much blue water to produce.
But in this concept, we can also consider green water. Is it correct?
You could do a virtual green water transfer. Yes, it applies to both. Yes.
Okay.
Yeah. The thing is, it's easy to understand why the virtual water concept is needed. If you, for instance, if you compare water with oil, like I mean petroleum, no? Okay, so both fluids, both necessary for a lot of things. One, oil, has a value such that it's pretty convenient to transport it, and also you use it in amounts that are relatively easy to transport. So you can put oil into barrels, put it on a ship, and bring it to where it's needed. With water, it's much more difficult. So one, it does not have that per unit volume value to make it worth being transported from one place to the other. Second, it's also heavier, that makes a difference. Third, you use it in a completely different way. Oil, you bring it to a refinery and you make the products there. Water, you have to put it over fields. So it's much more difficult to bring water to the exact point where you need it. So water transfers exist, like pipes that take water from one basin and bring it to the other, but are very few. You cannot set up a physical water trade system. It's, I mean, so only in very peculiar cases, mostly for potable water use, you have like trucks transporting fresh water from one place to the other. To do it for agriculture does not make any sense. And we know that agriculture is the main freshwater user. So this is why the trade in oil, for instance, is physical, while the trade in water has to be virtual because you have no other way to do it. So it's much more easier to produce something in a place with water, where there is water, and to transport the product than to directly transport the water in the place where you want the product. Okay, that's right. Okay. If there is nothing left, I just say thank you and goodbye and advertisement. So if you wanna get updates on, I mean, we've seen just a little part in this course of what is agrohydrology, what is ecohydrology, what is water and food security studies on the global or regional scale. If you want to know more about what we do normally, This is the website of our research group. We are on also in Instagram, LinkedIn, and Twitter. We are not on TikTok because we are too old. We are not on Facebook because we are too young. And this is our WebGIS platform where you can find all our specialized results with fancy colors and maps, and you can check out everything. I leave it here on the screen for you if you want to take a picture of the QR code or know the social media handles. And with that, for those who celebrate Christmas, Merry Christmas. And I'm remaining here if you have other questions for as long as you like. Thank you.